In this video, we're going to introduce you to SPSS. When you first open SPSS, you get a blank data sheet in the background and this little menu in the foreground. The menu allows you to pick old or previous databases or data sets that you've looked at in other files. You could click on new files, new data sets. That's rarely used because you're always going from Excel or something else or looking at an old file that you've already had. Over on this side we have tips. Each day you get a tip. You can hit the arrows to scroll through those. There is a help and support button. The tutorials are sometimes useful. A community to ask questions. If you do pick a file here, you can then just click open to open it. The first time you use SPSS, you should go through and select some options that you would like. One of the things that I did was I went through and on my viewer, which is the output screen, I changed the font size so that the things would be a little bit bigger on the screen. It's not much. You can't make them too big because then they don't fit on the screen and there's a lot of wrapping and it's really ugly. The other one that I find useful here is file locations. In R, we set a working directory. In here, you can do the same sort of thing, and I have chosen to go to my PUCO stats. This is the class, and so I'm saving everything in there. You should probably save your files the same place you saved your R files, or at least a place similar to that. And when you start your thesis, you should create a new file location, come in here and edit, so that every time you go into SPSS, you automatically save here. You don't have to mess around with changing the directory. Just is more convenient. There are other things you can look at, none really that you're going to need to change too much. Alright, so the first thing we have to do is open a file. Now, once that menu's gone, you don't see it again and while your session's going. So if you need to change or open other files, you have to go to SPSS's, the top thing. Up here we can see that we have various menu options. There's the file, there's the edit, which we just were in to get options. View, data, transform, analyze, graphs, utilities, extensions, windows, and help. Today we're going to talk about the file. We're going to do some things in data and transform and touch on analyze and graphs. Just briefly introduce several things in these areas. Alright, so let's get started. Now, as I mentioned, what you usually do is you go to data that's already been added in some way, either as an SPSS file, which you have .save files are the SPSS files. Down here you can see recently used data. So these are a bunch of different data files that I've looked at recently. Under recently used files, just general files, these include output files, which are SPV, and I don't see any syntax ones, which save your code. We're going to go to open data. Now we have a choice of data, internet data, syntax output script. So let's go to data. And in here, I've gone to the PUCO stats. We can come over here. One of the things, now it automatically comes up and looks for SPSS files, save files. But our data is often compiled in Excel. So we go down and we pick Excel. And now when we scroll over here, we're going to see all the Excel files that are in this directory. And we're going to look at none of these. We're going to go to the Chow study folder, and we're going to get we'll get unmatched Chow data. Now notice that this brings up a dialog box, and the main thing you have to be careful of is don't just click OK once that pops up. Make sure that you're on the sheet that you want to be on, because sometimes you have a sheet that you've set aside for graphs and data and stuff like that. You don't want to open that up. You want to get where the actual data is, and here it shows what we have. And the box defaults to reading the variable names from the first row of the data. So this pretty much follows the like we did in R, and we want Excel sheets, when we create them, to follow tidyr rules. There's only only row 1 contains variable names. Now that's not really the issue in tidy, it doesn't have to be, but in Excel we want row 1 to contain variable names, and we don't want to duplicate. So you might have a set of columns for baseline and a set of columns for follow-up. Well, you don't want to have spherical equivalent under baseline and spherical equivalent the same name under follow-up. You can have B spherical equivalent and F spherical equivalent, something like that. What you don't want to do is make two rows, the top row saying these are baseline data and the second row being the variable names within that. So everything sticks on one row. Do not leave any empty columns. Empty columns are disasters, because what will happen is in Excel, when you have an empty column, so say you want to separate baseline from follow-up, and so you say, well, they're kind of run together, so let's put in an empty column there to leave a space so I can tell where I am. Well, when you do that and you should happen to sort the data, it's going to sort only if you're on the left, if you're to the left of the empty column, it's only going to sort those rows and not the others, and you will randomize your data and be very unhappy. For one thing, you won't even know it until you're just sad that nothing came out significant in your results, and it's because you made a mistake in sorting. Every column is a single variable. So if this was Excel, you can see we have each column is its own variable. So for example, a common mistake in Acuity is to do 2020. Well, that's two numbers. It's the denominator of the Acuity and the distance that it's looking at it, or the distance that it's looking, and the Acuity. Every row is an observation, so we have our observations over here, and each one goes down. Now that doesn't necessarily mean every row is a subject, and we'll see this in a minute. But every row is, you want to get to that state. And every cell has a single value. That's the 2020 thing. If you're in Excel, then a handy thing to do when you're entering your data is, like, look at this data. If you come over here, there's values over on that side that you can't see. There's values down here that you can't see. And once you've entered this much data and you come over down to here, you can't see the data anymore. And you can't see what the variable names are, so you get confused. The way to get around that is to use freeze frames. So, for example, you can click in this column right here, or let's say gender base date. Let's go to base date. So wherever your cursor is, you're going to freeze the frames. So let's go to View, Freeze Frames, and we're going to go freeze right here. We don't want to do just the top row or the first column. We want to do where the cursor is. Now what does that do? You can kind of see it made these two lines. Now when you scroll down, notice you're going all the way down, but the column names are still showing. And when you go in this direction, the ID stays up, so you know where you are. All right. So there's some Excel tips for entering data. Okay, one of the first things you want to do is you want to, today we're talking about really in our introduction, cleaning the data. Some people have said you spend 80% of your time cleaning the data. And here we have, notice that in SPSS it looks very much like Excel. The difference is you do get a dedicated row to the variable names. And row 1 starts with the first piece of information. This is row 2 in your Excel sheet. Row 1 is the variables. All right, let's just take a look. We have axial length at baseline and axial length at 5-year follow-up. Let's plot that. So one of the first things we do is look at simple plots. So let's go to graphs. Now there are a lot of built-in helpful plot things like Chart Builder. You feel free to go in and use those, but I'm just old school and I go to their legacy dialogues, and I'm going to go down there. There's a number of plots you can make. I'm going to go to a scatter plot, a simple scatter. I'm going to define it, and I'm going to make the y AL5. So here's all my variables that I have. I'm going to go AL5 and I'm going to make that the y-axis. And I'm going to make axial length at baseline the x-axis. And something you can always do, which just makes things look a little better, you can set the markers by lens type. You can pick any variable. Maybe you'd like to look at it by eye and see if the eyes are the same, or look at it by gender and see if the sexes are the same. Okay. Now, here is our output. And with just that one simple thing, we get output that looks like this. Now, I have, at this point, we have lens type is 0 and 1. 0 is spherical and 1 is aspherical, but we'll see later how you can change that and label them. Very handy for documentation purposes. All right, how do we edit this graph? We double click on it. And then there's a few buttons that I want to point out that are very useful. One of these buttons is this one. Compare that to this one. The difference between these two is this is a reference line and this fits a line. So let's add our reference line. And what we get is, we see here, we get a formula, y equals 1.14. It just defaults to some line it thinks you might like. But we just want to do a line of identity. So we're going to put in y equals x. Now what does that do? And then you have to hit apply. That's one thing. You can't just change these values over here. You always have to hit apply, or it won't stick when you go away from it. So what is the line of identity? The line of identity says when x is 24, the line is at a point where y is also 24. So what this says, if you're on top of this line, if your values are above this line, then the y-axis has larger values. If you're below it, it has less. So what do we see here? We see that axial length at 5 years is generally longer than axial length at baseline. What about these little dots along here? It suggests that the axial length has shrunk. That's pretty unlikely. This is more likely to be measurement error. Now, when we do our analysis, we're going to do analysis of covariance, and we're going to adjust everybody for baseline. And as we measure the dependent variable AL5 and see if there's a difference in lens type. But the assumption for analysis of covariance is that these lines are parallel. So how would we tell if the lines are parallel? Well, we can come over here, we can do this button here that fits just one line, the best fitting line through this whole thing, or we can come to this one which has multiple lines in it with little dots around it. And so it's fitting to the subgroups, and the subgroups are what you set your markers by. So let's click on that. And notice that it puts in 2 lines, and it gives you the R squared, and for each of the lines. Now, it's a little hard to tell, but there's a 0 and a 1 there, and it's 40, and R squared is 0.4 for the spherical, that's this blue, and it's 91 for the green. So, are those lines parallel? No, they're not. So actually we're not really meeting the assumption for analysis of covariance here. And this could mislead us in our conclusions. Okay, so that's plots. I'd like to take a minute now and let's make this a little smaller so everything shows up. Unfortunately, in View, there's not a zoom feature. And we're a little cramped over here. I'm not quite sure why that is. Oh, there we go. Okay, let's look at our output. Our output has 2 sections to it. It has this outline, and it has the results, the output, whatever you want to call it. Notice it gives you the syntax of what you have. So we just clicked on graphs and picked something, and here's the syntax that you would, if you could actually save this into a syntax file and run this code and get the same thing as we did with button pushing. So here it shows we're getting the data and the Excel data, and that's just an execute. It executes this get data command. That was when we opened our file. On this side is an outline. Now, after you've been sitting here for a while doing a lot of different things, this is going to get very long and it's hard to find stuff. So you can come over to your outline, which condenses it a lot, and you can just click on various things. So you can click on the graph and the graph pops up. You can also reduce it, the size, as you go down here. You can kind of suppress things and then expand them, and then what you get is a list of all the things you can find what you were looking for to do before. So one of the nice things about R was we could just run the data again from the code. Once you've turned off SPSS, you don't really have that potential again to go in and edit things you've done before. Not very easily. Anyway, there's a very complicated way that you could do it, but we are not going to do it in this course. Okay, so let's take a moment and look at the data. So this is the data that comes in, and we'll see, look at this AL change. It's got all these decimal points. How do we reduce those? Or in the case of the lens type, we have zeros and ones. We'd really like to see names for those. So there's something down here. We're in data view. Let's go to variable view. And remember that change, these have the change, the axial length change has a space for 22 digits, 15 of them are decimal points. That's not very useful. We can count them down, or we can just change that number to 2. Alright, and then we can copy it. This copying it doesn't always work. There's a special place you have to get to, and it's hard to say where that is. So I am, oops. So what I have done here is I'm sitting on this 15. I'm just going to hit the number 2. And it goes in, enter, hit 2, enter. So now we have decimals. We have the name, we have the type of data that it is, we have the width of the column, we have how many decimals, then we have a label. So we can put in our label lens type, or we can leave it with no space and the word. SPSS prioritizes the label if you use it. Now, one of the problems that you've got this data set and you leave it for a while and you can't remember, was lens type 0 spheric or aspheric? So one of the things you should do right away, this is like in R when you had a factor and you set the labels, set the values. Here we're going to set our values. We're going to say 0, and on this one you hit 0, then the tab key, and you type in, you can do it with your cursor too, it's just easier to go down with the tab key, and then type spherical. And then you have to remember to add. And then 1 tab aspherical. Now, at this point, it's oftentimes tempting just to say OK, but you haven't added it yet. So remember, on the last one, you have to hit add. It'll give you a warning, but still. Now let's look at our data. Now look at lens type. Now it's not 0 and 1, it's spherical and aspherical. It has replaced these. And actually, if you click on one, you can see it's still, the data itself is still a 0. it's just showing you the label. And then if you do a t-test or something to compare aspherical and spherical, the output will not have 0 and 1 like our graph did. Well, actually, if we do our graph again, we see that now it has labeled it correctly. All right. Let's go back to our data. Our e-values are still pretty bad in terms of the number of decimal points. So let's go to e-values, and let's give them 2 also. And let's not make this 32 wide. Let's make it 6 wide. And we look up and down, no more super giant numbers of decimal points or widths. Go back to our data view, and we see that e-value is now a more reasonable looking number. Now, when you do computations, it ignores this formatting. This formatting is only for the viewer. It will use the original data to all its decimal points. So that can be a good or a bad thing, but it's how it works. All right. Also, under variable view, you have a column called missing. And sometimes it's handy to, if you have a missing value, or let's say you're taking a data set that maybe you haven't put in, but it's a survey, and the survey people say, okay, missing values are 99. Well, you can come in here and say, you can give it a number, 99. And so it will set to system missing any value that's a 99. I don't have any 99, so nothing's going to happen there. The other thing that, for example, if you use some of the more automatic features of SPSS, like in the graphs, if you use those things on the top, it's going to want to know what is the scale that you have. So in this case, it looked and it figured out that lens type was nominal. It doesn't always do that. It may not have said that before we gave it labels. These are scale, and notice your choices are scale, ordinal, and nominal. So if you're doing like a BIV scale, and it goes from 1 to 5, then you would call that ordinal. And then when you go to nonparametrics, if you use their help, it will it won't allow you to do statistics on if the statistical function requires interval data. It will only give you statistical options for scale data. Okay, let's start doing something. So let's look at our data again. And if we come over here, we notice our IDs are not in a very good order. They're kind of random. And we also notice that we have 2 I's, and in this case there's 2 rows for each subject because they have 2 I's, and the data was measured for each I. So let's sort by ID and I. And the way you do that is you go to Data and then Sort Cases. There's also a Sort Variables. You hardly ever use that one. But if you have a giant data set, it's sometimes handy to sort by variables because it just alphabetically puts them. You can find them easier. It gets pretty hard to find stuff in a really long database. So let's sort our cases. You click on that, and what do you want to sort by? Well, I want to sort by ID, and I want to sort by I. And both of these sort orders I want to be ascending. That's going to put the left eye first. Now we always think of the right eye as being, because L left comes before R right. So let's make I descending, because we always measure the right eye first. Now we can save a separate file of the sorted data, but generally you don't do that. Let's just say OK. So it pops into our output. It tells us that it has sorted the cases. And then let's look and see what it did. So here we have subject 1, right eye, left eye, subject 2, right eye, left eye. So we did a descending sort on I, so the right eye came first. Now another, just to kind of show you different things in here. One of the early, or when you're computing your data or compiling your data, let's say you have you've got day 1, or you've got your measurements. So you measure a bunch of measures from the OCT, and you have a data sheet for OCT, and then you have another data sheet for things like acuity and contrast sensitivity. In each of these data sheets you have your ID number, and then if you measure them more than one day, you might also have the visit day. But you want to be able to compare, and then you have another group that says, well, it says the treatment group, or even on a particular day you might have the treatment group. So you want to know, you want to compare treatment groups, control versus placebo, for OCT, or maybe you want to you want to look at both OCT and acuity at the same time, but they're in separate sheets. You've brought them up as separate saved files. Well, you can merge them, and they're separate files. They're not more cases. The IDs are the same. You still have 30 subjects. It's just that you have more variables, so you want to add variables. And this will give you a set of all your data, all your data sets available that are active. I'm not quite sure why it's not showing the untitled one here, but you can also browse to find all the different ones that you have. Most likely what you would do is you would open your OCT file, you would open your demographics file, you would open your just general acuity measures, and then you would say these are the ones I want to use. It's not going to let me go on without real data here, but you then link them together, and now you have one big file with all the data. So for when you're collecting your data, you can keep stuff separate if that's more convenient to you, and then combine it later, or you can put it all in one sheet at one time. It's really kind of up to you how it works best. Another feature in this is Aggregate. Now we saw that in R, where we were grouping by some feature, some maybe treatment or something, and then we saved it into a new file. Well, Aggregate saves a new file, and for example, we might want to average eyes, because we have 2 eyes here. Maybe we just take the average to get at something. We really don't want to do that, but let's say if we did. So we can. This is what it's going to break by. It's going to give us a new file where now there's only ID 1, 2, 3. That's not 1, 1, 2, 2, 3, 3. It's just going to have the 1. If we put in I, we would lose the fact that we're averaging over that. But if we don't add I into this break, and we go to these other variables, let's say we're going to have sphere, and we're going to go down to all these variables, we stick them in here, and it's going to summarize each of them, and it's going to go like, here is AL0 mean, and it's going to be the mean of that. Now we can choose different functions. For example, in our vision database we have a number of different visits. We just maybe want to look at where did they start. So we would do an aggregate file where we just pick out the first visit. In this case, we're taking the average of the two I's. And then we can, in the case of the vision file, people stayed different number of visits, so we could add a thing on how many visits are in this, contained in this data set for each ID, and so you create a new variable, or not. So in this case, everybody has two I's, so it's not really giving you much information. Now, the first option is add aggregate data variables to the active data set. That, I don't like that one. It sticks on new variables at the end of your data set that are the averages of all that. It's not very useful because you still have multiple rows, so it just makes the analysis confusing. Now you can either create a new data set, which is just in memory, or you can write a new file and give it a name. I tend to do this, and I'll go ag chow I. So I'm aggregating the chow data set in the I, and that's the name. I would probably also save it with a name similar to that. You can tell it if the file is already sorted to save it some time, but it's not really it is important to get the things together that you're doing, because it will, as it goes through, it will aggregate based on. So if you had a bunch of visits and IDs and they were not all together, it would potentially mess up your aggregation. So let's save that. And then what happens is that, I'm not sure how it works on a Mac, but here we see when we go click on the SPSS icon, we get this blank thing up here, log chow I. We click on that, and now you see we have ID 1, 2, 3. There's no longer an I in there. We just have the variables that we saved, and these are the means of everything. These are the means, and notice it says mean. And you can leave that like that. What I tend to do is go to variable view, and in variable view you can go through and copy each of these, edit, search for, oh, that's help topics. I'm looking for find. There may or may not be find in here. Oh, it's there, it's just grayed out, so it's not, you can't really do this. So what I usually do is I copy this, take it into Excel, search and replace for underscore mean, and get rid of this little phrase, and just copy back sphere, cylinder, axis after mean has been deleted. It just cleans it up a little bit. It's not really necessary. Notice we did not include lens type here, which was not a good idea because we really want to do that. Alright. So that's aggregate. Now, another thing that's another way of doing this, let's go back to our previous data set. By the way, this says Untitled, and you can see this little asterisk. That means we haven't saved it yet. And so let's go ahead and save it. File. Notice, oh well, that one stayed there. If we hadn't gone into that file before, it might change, but this is, and it's now going to save it as a save file, and so it just shows all SPSS files. And you can replace one, or you can just give it another name and save it. And now the asterisk has gone away, and we've got this file called test. All right, split files. We go to data. Now, if we come down here, we can see there's split file and split into file. We don't want split into file. Split into file creates separate files for whatever the variable is we're splitting. Split file lets us compare groups, and let's say we want to do a t-test on lens type. Well, we can't just go in and do a t-test on lens type for, say, sphere or axial length or anything else, because all the observations are not independent. We have a left and a right eye. So we don't have 586 observations. We only have half that. So we don't want to do the test. So what we can do is we can analyze based on each of these. Now, one of the things we might want to do is, well, if we separated by eye, we could run any analysis we wanted to, and it would do it twice. It would do it once for the left eye and once for the right eye. Another thing we can do is we can compute the means. So let's go to split file. We're going to compare groups, and let's compare groups by lens type. Well, let's do eye first. Eye, and then lens type. Now, when we split the file like that, it just puts out this log. Unfortunately, my output screen is thinner, so I can still see this one. But now what it's done is we've split it by file, and so we've got spherical left, aspherical left, spherical right, and aspherical right. So we have these 4 subsets of our data. Now, let's take the means of everything. So to do that, we're going to go, there is this Analyze menu, and these are all the different things that SPSS will do for you. We're just going to do Descriptive Statistics, and we can do counts, that's frequencies, or we can go to descriptives. And the descriptives, we can again do all our baseline measures and our axial lengths, them in there. We can just hit OK now, or we can choose the values that we want. It defaults at mean, standard deviation, min, and max. You can also do bootstrap means. I don't know if you have that option, but if you do, you can get bootstrap means, which just it calculates, the means are the same, but it calculates the standard errors a little differently. Okay, let's do that. And now in our log we can see we have the left eye and right eye stuff, and we have aspherical and spherical, and then we get the n, the minimum, maximum, mean, and standard deviation. So that's how we would kind of compute things. So if you're doing a table 1 with your demographics, you can split things by groups and then put that out and then arrange it like you want it in Excel. Now note that we have our lens type was originally 0 and 1, so it has labeled it this way. It's making life a little bit easier for you by putting out the labels. I was coded as left and right, so we didn't have to do that for that. It's much better to code your data as 0 and 1, so make left or right 0 or 1. Also notice it does it alphabetically. We can't make it go right then left like we can when we sort the data. But you can, but it's better, rather than writing out the word left, to just give it a 0 and give it a 1, or vice versa. The reason for that is SPSS will see capital LEFT, lowercase LEFT, lowercase LEFT space as all 3 different ways of identifying this particular I. So it has to be, the spelling when you're doing the data entry has to be too exact. Plus you're typing 4 letters instead of 1 number. So it's just easier to code in numbers and then label them. But you have to label them right away so you don't forget which is which. Okay, so another thing we can look at is select. This is a common one. This is like filter in R. Data split was like group by, and select is like filter. And if we look at that, we can set conditions. So let's say we want to only look at, I think we only want to look at, let's say, spheres that are, now here's a little table. You don't have to use your number pad. You can just come over here. So you want spheres that are less than 0. Our data set originally had, and may still have, some positive spheres for myopes. This is a myopic data set, so nobody should have a sphere greater than 0, and if they do, it's probably a typo. So we can set sphere less than 0 and continue and OK, and then we can look through here our data set and see if anybody was eliminated. So were there any cases where sphere was greater than 0? And what we're looking for is slashes in the column, so that's not going to show it. So what we can do, so let's give an example so you can see it. Select if I, and these are characters, so we want to put it in quotes. We're selecting if I equals left, so we come down here, left, 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 left. And when we get to right, we start getting a right eye. It's got this little symbol over here that indicates that we're not looking at those values. All right. Another thing that we often want to do is compute a variable. So let's say we find something that is kind of skewed and we want to give it a log transformation. So how would we do that? Well, we go up into transform. I have a musical interlude here. We'll go to transform and we're going to go to compute variable, and let's say we want to take the log of, I don't know, we'll take the log of sphere. Now, when I do a log base 10, I do LG. When I do base E, I do LN. So I'm going to do a base 10, and we're going to have the log of sphere. By the way, case, unlike R, case does not matter so much, except when you're trying to, when it's trying to do the values in the data sheet itself, it pays attention to case. But the variable names, you could do all caps sphere or all lowercase sphere or whatever, it doesn't matter. Now over here, there are a bunch of functions. And here's all of them. These are all the functions available to you. Here's log base 10 and natural log. You can also find those under arithmetic. If you know where it is, it's a shorter list. It's easier to use. So here's log 10, and then it has this little question mark, which actually is kind of annoying sometimes, but we're going to do sphere, and we're going to insert it in there, and now we have log 10 sphere. So that's showing you, or that's going to take the log. So let's do that. And then when we come over here to our data sheet, go to variable view, we're going to notice that log sphere is put in at the end. And so we get all missing data. I didn't think about that. Why do we have all missing data? It's going to be completely missing. Did it not work? No, that's not the problem. It worked fine. It's just that all spheres are negative. And so you can't take the log of a negative number. Now, if you have a distribution that has negative numbers, the way you get around that is we'll take the log of the sphere plus 10. Do I want to change the existing variable? Yes, I do. Okay. And now we come out and we come over here and we see that now that we have a log value. So now we've converted from arithmetic to log. Now when you want to convert that back, you have to remember that it's 10 raised to the power of log sphere minus 10. Okay. So next let's talk about in our transform recoding. You can recode into the same variable or into another. So let's say we want to recode and we want lens type, or let's say we want I. No, lens type. Let's say we want to make lens type, for some reason, we want to make lens type for a sphere 0 and spherical 1, because right now it's the other way around. So we go to old and new values, we take the value 0 and we make it a 1 and add it. And Excel's actually smart enough to know that now that you've made all those zeros ones, they aren't ones when we calculate 1 and make it a 0. You have to remember to add it. You can also, if you have missing data, you could give it a particular data. System missing is a dot in SPSS. It shows up not as a blank, but as a dot. If it's in a range, let's say you've got 1, 2, 3, 4, 100, and anything over 5 you want to set, you can say values from 6 to 100 is a 5. You can do it, well, the highest is like the lowest. You just take the number range of the value through the so if you put in a 5 to the highest number, you can put that in there, and then it will and then up here you put 5. It'll change everything greater than 5 and make it a 5. So that's useful sometimes. Okay, I'm not going to run that. I don't want to confuse myself later. So there you go. You'd also have to change the labels. So that was recode. Recode into a different variable is the same sort of thing. But you go over here and you put in sphere, and then you can give it a new name, new sphere, and then old and new values, and maybe you want to make sphere's not a very good example, but you could give it a new value for each of the values. That's kind of not a very good example, but you can see. So if we were doing lens type, you could give a new variable name and not overwrite the old one. Okay. Now let's look at some features in Analyze that are useful for cleaning our data. One of the things up here, we have power analysis. So this is like our little Excel spreadsheet. You get the same answers out of here as you would for power or the means and independent sample t-test. It doesn't have ANCOVA, so you have to do another little calculation yourself after you get the sample size. But let's look at descriptive statistics. We've already seen that we have descriptives, and that gives us the means. We can do frequencies. So let's look at frequencies. And let's look at frequencies for sphere. Now, that has a whole lot of values, and one of the things you want to look at, say, the shape of the curve, you can go to Charts and choose a histogram. You can check this to show the normal curve on given that same range, but well, we'll do that. Don't really have to do that. And we'll continue. Now, sphere has many values, so you don't want to display the individual frequencies. So, well, you could. Let's do it just to see what we get. So, okay. So here are all the values for sphere. Oh, and it's split too. That's nice. And here is the graph. Here are the histograms. So you get an idea of the shape for the different conditions. This is left eye, the spherical lens type. This is left eye, the aspherical lens type. Oh, we've deleted all the right eyes. That's why I can't find it. We've selected out our data. That's one thing you have to be careful about when you select cases. You get rid of them only when you want to. We can go in and delete this, or we can just say all cases. All right. Another thing in Analyze is we've got this way of looking at our histograms. We can go into Descriptive Statistics and see our QQ plots. And we can look at sphere. And you can have a number of tests. You can compare it to the normal, the log normal, logistic, a whole bunch of things. Generally speaking, we're going to stick to normal. And OK. And what it gives you, now see over here on our outline, we can look at the QQ plot for the eye, the left eye, and the spherical lens type. So let's just click there. And you can see it's kind of straight, but it's kind of off at the ends too. So that's a questionable one. The good news is that analysis of variance, if we were going to use that or other things, are pretty robust to this lack of normality, but only if the sample sizes are equal. And if they're too unequal, then that would probably affect things. We can either scroll down, well, this is a detrended thing. This just takes the residual and plots it. We don't use this very much. Here's a normal QQ plot for the right eye, lens type aspherical. Not too bad. Sometimes we want to check and see what we have in terms of how many things do we have under each of our conditions. We can go to Analyze, Descriptive, Crosstabs. And in our rows, we can put eye, and in column we can put lens type. And then we can choose what we want to do, what we want to see on this. Now, I tend to like to show expected values. We'll get into this more when we talk about frequencies and proportions. Row and column, percentages, and standardized residuals. So let's see what that gives us. Oh, that's the other thing. It's telling me I split my files on the variables I want to look at, so it didn't like that very well. So just like select, we can go to split and analyze all cases without a split. Now let's go Analyze, Descriptive, Crosstabs, OK. So what has it done for us? Here is eye, left and right, and total. And the raw counts are 164 spherical for the left eye, 129 for the right. That's the same for the or for aspherical. That's the same for the right eye. And then, well, that's it. So we have 164 in each left and right eye, and 129 in each left and right aspherical. So we have more spherical lenses than we do aspherical. The expected count by chance, this isn't too useful here because everybody's pretty much the same. There is no relationship between lens type and eye because the left and right values are the same. But adjusted residual just lets you know if your distribution, if it's not equal, if you reject the null hypothesis that everything is random, this will be a number that's kind of big. In this case, it's not doing that. It's a 0. We'll get into this more when we talk about proportions. Okay. Finally, I would just like to mention again the output file. If you look over here, there's just a lot of stuff, and it's hard to find. Scrolling through, it's just a little bit of a pain, whereas you can see what you've done for the day over in the outline pretty easily. We had 2 graphs, 2 scatter plots, descriptive statistics. We had some frequency histograms, some QQ plots, and it can all be reduced. And come on, give me that little guy there. There we go. And you can cut them down or look it up. It's just easier to find stuff. And as you go through and you make a mistake, like I made a mistake on this one. I see the warnings. You look over here. If you ever get warnings, you've probably done something wrong and you want to fix it. So this kind of brings that out right away. And you don't want to remember this particular one. When you're going over it, you don't want to have this muck up your data, so you can highlight it and delete it. And now you just have the stuff in there that you want. That's good for reporting and keeping track of what you're doing. So that's our introduction to SPSS.